So thank you very much, and thanks again to the organisers for inviting me to come and speak today on a topic that I am really passionate about, because it's taken up about 3 years of my focus, trying to do my PhD and trying to really understand about heterogeneity in MND, what it means to us and how it really impacts all of us, patients, carers, clinicians and researchers, and what we need to do to understand and dissect the mechanisms further. So hopefully I can share a few of my thoughts with you about this, show you some of the patterns that I think we've found in the puzzle, and take you through what I think we need to do for the future. So heterogeneity, as Susan also alluded to, this is the actual definition of it, and it's the quality or state of being diverse in character or content. And I thought this is really typifying some aspects of heterogeneity that we see in MND, and you'll probably recognise some faces here, if not all of the faces. And I don't really know why, but all the Australians are in colour. That wasn't intentional, but they are. So you can see Neil Danaher there, and Cookie Monster, and Sesame Street producer John Stone. And a few other people there that you might recognise, Stephen Hawking when he was very young. But for me, it was really this guy here, Dmitry Shostakovich. So he's a Russian pianist, and when I was playing the piano, I used to play a lot of his works, and I read about him and how he had this very slowly progressive, very insidious onset of an asymmetrical problem. It was in and out of hospital. He lived quite a long life, but he was marred with this ill health and actually never got a diagnosis. And for me, this really typified the heterogeneity that we can see in MND and how there are these atypical cases. Now, retrospectively, people have gone back and looked at his medical records and his case files, and they've said, yes, this was an unusual atypical variant of MND. And now we are recognising more and more that the atypical might be more typical when we talk about MND. So for me, that was really something that stood out. And it's these dissimilarities in between patients that really make these diseases very complex, and it renders some really basic questions very hard to answer. And I think they're still really hard to answer. And sometimes you think, you know, these are the basics of any disease. These are the first three things probably anyone asks me when they walk into clinic and if they're diagnosed with MND. But the heterogeneity has made this really, really difficult to answer. So, I mean, the first thing is, you know, is there a diagnostic test? How can you confirm my diagnosis? And for some people, we can't really do that until the test of time has really gone through. What's my prognosis? Now, that's the other question that comes up all the time that can be quite difficult to answer. And of course, the holy grail of questions is, you know, after more than about 150 years, where's the cure for this? We've done a lot of work in it, and why can't we find the cure? And I think a lot of these things are typified by the fact that we're dealing with many faces and maybe one disease, as Susan alluded to earlier. And for researchers, we're particularly asking this question about whether we're dealing with one disease that has many faces, or are we dealing with actually many diseases? Now, I have to confess that when I saw that Beatles cover, I thought it was one person. That's why I put that up there. So you can see how much of a Beatles fan I actually am, and my husband had to tell me, no, actually there's 4 different people in there. But it looks all the same to me. So I thought it was all one. I'm very sorry if there's any Beatles fans in the audience. I thought that was just one person making all sorts of different faces. I thought this is perfect for a cover of that. But so apologies, but that was the idea of why I put that there. Is this MND looking in all sorts of different ways, but it's actually one disease? And the other one is, does anyone know what album cover that is? I nearly gave it away. It's The Who. So I think The Who, that was the 1981. And it featured many paintings of many British painters, different British painters. And are we looking at this constellation of different people, different faces, or are we looking at, well, not the one, but just assume that's one person. Are we looking at the one person that's looking in various different ways? And that's a question I think we might be closer to understanding, and I'll tell you what I think my personal opinion from some of the research that we've done. So I want to kind of go through a few things that contribute to disease heterogeneity, and because it's such a broad topic, I'm just going to really focus on clinical heterogeneity and MND as a multi-systems disease. I'm going to try and introduce the idea of the impact of heterogeneity on all of us and all the things that we're doing and how it should impact everything we're doing and how we think about this disease. Talk a little bit about what's new in research and what we've been trying to do to understand the heterogeneity a little bit better and to really dissect the mechanisms under MND, and then what do we need to do to get these answers and really to strive towards treatment and a cure. So we all know that MND really involves failure of the two major motor systems. So we've got the upper motor neuron system, or the central system with the brain and the spinal cord, giving us the signs and symptoms that we see there. And then we also have the involvement of the lower motor neuron systems with signs such as muscle wasting and weakness. And this makes it a very unique disease. One, it's very unique because not very many neurological or neurodegenerative diseases involve both of those systems, so that makes it unique in itself. And it's unique to the human species, so we don't, in a number of ways, it's already complicated to start with. But we also know that within the clinical syndrome, we have many different clinical phenotypes, and a phenotype is the characteristics that we see, so their appearances, the presentations in clinic, and the different behaviours that we normally see. And we looked at the different types of clinical presentations recently in a review, and we can see that there are three main drivers for clinical heterogeneity. The first one is the site of onset. Susan was saying that we don't really know whether it's going to start in the arm, why does it start in the leg for some people, why does it start in the bulbar region for some people. So the site of onset is one of the main drivers of the clinical heterogeneity that we see. The other main driver is really this mix of upper and lower motor neuron involvement. So we don't know why some people really fall onto one spectrum and have a lot more of the lower nerve system involved. Why do some people fall onto the other side of the spectrum and have the upper nerve system involved? But that really gives us a big diversity in the types of patients that we do see. And the third thing is really the rate of disease progression. And the rate of disease progression is very heterogeneous. And I think this really shows you how, this is only 30 people, believe it or not, in this spaghetti plot, but this is really tracking their functional status across a number of months. And you can see how everyone's lines are different and they're going in different directions and different trajectories. And this makes it very difficult in terms of identifying one phenotype. So this really gives us that clinical heterogeneity that we see. But we know within this that there are patterns, and the four main clinical phenotypes that have been described, I'll just go through them. The first one that you'll probably all know about is amyotrophic lateral sclerosis. So that really exemplifies about 70% of the cases, so the majority of the cases that we know of MND. Classically, we know it would begin in a limb, and it generally has a fairly even mix of upper and lower motor neuron symptoms and signs. The second one is the progressive bulbar palsy that we heard a little bit about just before, and that's really 4 to 8% of the cases, and that's defined by just the speech and swallowing issues for a prolonged period of time, and we kind of label that as more than 6 months, with the limb strength still being quite preserved. We know that another pattern that we can find in this clinical spectrum is the progressive muscular atrophy type pattern, in which patients have just the lower motor neuron signs for a long period of time. That we define as 12 months, and that's about 5% of the cases, and that can happen either in the arm or the leg, and we call that flail arm or flail leg, depending on which one. And that really is in the lower motor neuron spectrum of disease. And then we've got, from the other spectrum of disease, the upper motor neuron spectrum of disease, primary lateral sclerosis. So again, that's 1 to 3% of cases, and you have to have pure central signs, so there's upper motor neuron signs only for about 3 to 5 years. And generally, patients have a lower limb onset, but again, that's a little bit variable. But these patients have to wait a little bit of a while, at least 3 years, to have a definitive diagnosis to prove that there's no lower motor neuron changes that will make them fall slightly into the middle of that spectrum of disease. So they're the four main clinical patterns that we see. Now, to add some complexity onto even that, We know that there are non-motor systems that are also involved. So in some patients, they have sensory symptoms, so pain or tingling or numbness. And we looked into that, and we've been trying to find out where is that actually coming from. In some patients, they have problems with their balance and coordination. Some patients, of course, have some rigidity and slowness that's almost a little bit similar to something like Parkinson's disease from a similar pathology or area of pathology that's involved. And for some patients, there's even autonomic dysfunction. So this is up to about 50% of patients might have some trouble regulating their heart rate and regulating their blood pressure or regulating their urinary and gastrointestinal symptoms. So this adds another layer of complexity onto those motor phenotypes that we now recognise there are some non-motor symptoms too in MND. So this really brings it together as a multi-systems disease. It's really a syndrome now that we recognise. And again, it's that question, which album cover are we really going to pick with this? It's a tricky question, which I clearly missed. So why is this a problem? Why do we worry about the heterogeneity? What does this really matter to us? Well, it's a problem for a number of reasons. Firstly, diagnosis can be delayed. We know there's no diagnostic test for MND, so any variability, anything that's kind of not within the what you would think is typical is always going to raise some extra questions. And in MND, with no diagnostic test, we need to rule out every single possible disease mimic, particularly if we have non-motor signs that really come up as red flags for potentially being something else. It takes longer to make sure that we can rule every single thing out that might be potentially treatable. So that really prolongs diagnostic delay. So that really impacts for the patient as well as their carers and their families. The other thing we know is that prognosis is also linked to the type of phenotype that they have. So one of those 4 patterns that I was describing is actually linked with prognosis and outcome. And even though we probably all know here that the most common type we generally talk about is 3 to 5 years, we have a large spectrum of prognosis. And particularly if you're on the ends of those spectrums with lower motor neuron only or upper motor neuron only disease, you can have a very different idea about prognosis and disease trajectory. And I think we're starting to recognise this, and we're starting to decide that we need to actually incorporate this into our classification. We need to incorporate heterogeneity into how we actually think about patients, because it's affecting their prognosis and their outcomes, and so it's a very critical thing in the management of patients. The other thing is we don't really know, when everything's so variable, how the disease progresses. A lot of people think it dies forward from the brain, that there's some hyperexcitability. We heard about this yesterday in mice models as well as in human models, that the neurons in the brain are hyperexcitable, and perhaps that's the toxic drive downwards into the lower motor neurons. There are some people who think that it's dying backwards from the lower nerves to the upper nerves, and some people who think that the upper and the lower systems are very independent of each other and doing their own thing. So when we've got such heterogeneity, those kind of things are very difficult to untangle. So I want to talk to you a little bit about quickly about some new tools and techniques that are really pivotal, because we need to understand the disease better to be able to get the right treatments for the right people, for the right subgroup. So understanding the heterogeneity is actually the key to actually defining what we need to do in terms of clinical trials and treatment. So 2 things that I've just picked to talk about, because we do them and I've been doing them as part of my PhD. So the first thing I wanted to talk to you about is transcranial magnetic stimulation. You'll probably have heard about it before, but this is really a device looking for upper motor neuron changes and looking for that cortical hyperexcitability, those overexcited nerves. And it's important because it's actually quite hard to assess the upper motor neuron in ALS, and maybe even about 10 to 15% of patients don't have obvious clinical signs. So we need a tool to be able to help us detect that. And really briefly, what it involves is just magnetic stimulation to the motor cortex. We record the response distally in a limb, generally the upper limb, and we can get a number of cortical parameters that tell us about the state of the networks in the brain, the inhibitory networks and the excitatory networks. And probably the most sensitive of those markers is this thing here called the SICI, which is at the start of this graph here, if you can see my mouse at all, but it's at the start of that graph. And you can see in controls in the red, so they're patients without MND, they've got a big inhibition at that point, whereas in the MND patients in blue, they've lost that inhibition, and they've lost it because their cells are really hyperexcitable. So this is something that Steve and Matthew have done a lot of work on and have seen that this is an early pathogenic mechanism, but it helps us differentiate ALS from disease mimics as well, with a reasonably good sensitivity and specificity. So I wanted to see are there any differences within the subgroups, so I designed this 4-limb type method to do that. I'll give you just the highlight reel. Basically, it looks like there's hyperexcitability everywhere in the brain, so it is a definite phenomenon. Whether you look at the legs or whether you look at the arms, the hyperexcitability is in all those regions of the brain. And it corresponds to the clinically affected side. So what we're seeing with the patient is happening to some extent in the brain as well, so that's really important. And when we look at the subtypes, it's the same thing, but the main thing with the subtypes is it's very focused. So in the upper limb onset patients, there's more changes in the upper limb area of the brain. In the lower limb onset patients, there's more changes in the lower limb onset part of the brain. And that's very exciting because it suggests that maybe there's a regionality of the problem. And if we can contain a region, we might be able to contain the progression of the disease. So these are all concepts that are very interesting, but it does show us that across the subtypes, it looks like it's the one mechanism happening in different ways across the subtypes. So I think it's the one person on this album cover. Let's call him John Lennon. One person making very different faces. So I think it's many faces of the one disease. Now I'm not going to tell you about this because the bell's already gone. But just very quickly, I think a lot of our understanding really relies on the fact that we've got so much advocacy, collaboration, days like this, we can talk and communicate with patients and carers and other clinicians and researchers, and without that and keeping that door open, we really, that's really what's driving a lot of this research and understanding. And MND Australia, MNDRIA and other such institutions really let us have that bridge that I think is really fostering this awareness and this extra drive. And in the end, we need to use this knowledge and tools to try and get a better understanding of those motor systems and heterogeneity and really reflect that in what we do, whether it be research or caring for our patients. And we want to try and find the biomarkers that Susan was talking about to get earlier diagnosis, to clarify prognosis, to try and predict how the disease is going to go, to look for these hot spots in the brain if they're relevant, and really, like as Susan also alluded to think about how we're going to do the trials, whether we subdivide patients into actually what their disease looks like from an upper and a lower motor neuron perspective, or from dissecting actually what's happening as a mechanism. I'll just leave you with this, which is a quote from the 1800s, which said it's much more important to know, so this is William Osler, much more important to know what sort of a patient has a disease than what sort of a disease a patient has. And I think that's really particularly apt when we talk about clinical heterogeneity and really listening to our patients and looking at what they're giving us, the information that they're giving us, and working out our research and our future treatments from that perspective. So thank you very much. Thanks for your time.